Okay, everyone, this is going to be a quick video to help explain negative exponents. So let's review the positive exponents. If you have a positive exponent, for example, 5 to the second power, or 5 squared, that's considered 5 times 5, or repeated multiplication, and you get 25. When you have negative exponents, you're actually doing the opposite and you're doing repeated division. So let me show you how that works. In this particular problem here, all of these 5s really have a 1 underneath them. So all the numerators are getting multiplied and the denominators. In negative exponents, you're actually going to flip your base. So if I have 5 to the negative second power, I'm going to be dividing by the 5 squared. So what happens is this 5 can really be written as 5 over 1, and that is being taken to the negative 2 power. So to express what this value is, you are going to have to flip your base. You'll get 1 over 5, and you keep the exponent that was with it, but it's actually positive now. When you switch it to the fraction, you now switch the exponent to positive. The negative 2 just represents that this answer is going to give you a fraction or a decimal. You're making your number smaller than what it was to begin with. The positive makes your number bigger than what it was to begin with. The negative makes your number smaller. So this actually turns into 1/25th. So instead of just coming up with 25 as an answer with a positive exponent, you're actually dividing by 25. So you get 1/25th. So let's try another one. Let's say you have 2 to the fourth power. You would have 2 times 2 times 2 times 2, and you get 16. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But what if you have 2 to the negative fourth power? That actually means you're taking 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. Or you can rewrite that as flipping your base, 1 over 2, and you keep your exponent with the 2, and now I get 1 over 16. So what I'd like you to see here is that when you have 2 to the fourth power, you actually get 16 over 1. If you have 2 to the negative fourth power, you get 1 over 16. So the 2 to the 4 gets placed on the bottom as a denominator when you have a negative exponent. So let's try another one. So if you have 7 to the negative second power, that's actually 1 over 7 times 1 over 7. And that's 1 over 7 squared, which is basically flipping this base and keeping the exponent with the 7. And you get 1/49. Now, once you get the hang of it, you won't have to do all this work here. Let's try another one with just a 2 as an exponent. So let's try 8 to the negative 2 power. Well, I'm going to flip my base. Well, this is really an 8 over 1. So I'm going to go 1 over 8. So I flipped it over. And I keep the exponent with that base. So I get 1 over 8 squared, which is 1 over 64. Okay, so let's try some that have to do with some exponent rules. So what if we had something like 2 to the third power times 2 to the negative fifth power, and you were to use your exponent rules to figure out the answer to that? Well, I have same base being multiplied, so we can use that exponent rule where if there's same base being multiplied, we can add the exponents. But what happens in this one is when I add the exponent, a 3 plus a negative 5, I get negative 2 as my exponent. Well, I need to change my answer to make that into a form with a positive exponent. They don't really like you to leave your answers with a negative exponent. So this would turn into 1 over 2 squared, which is 1/4. Because I flipped my base, this is my base, I'm going to flip it over because this is really a 2 over 1. flip it over, and keep the exponent with it. And so this answer equals 1/4. And what about one with a division? So let's try something like this. What if I had 8 to the third power, and I divide it by 8 to the sixth power? Okay, we have same base being divided, so I can subtract my exponents. But remember, you have to subtract top to bottom because this is just 3/8 getting multiplied together. This is 6/8 getting multiplied together. So when they cancel out, you do have some left over, but they're going to be on the bottom. So you have to subtract top to bottom. So you get 3 minus 6, and I get -3 as my exponent. So I keep my base, and I have a -3 as an exponent. Well, that means I can't leave my answer this way. I need to flip my base. So now that's 1/8, and I keep the exponent with the 8. That means I have 1/8 cubed, which is 1/512. Okay, now what if we had something like this? What if I had 7x to the -3 power? Well, this is the same thing as 7 times x to the -3 power. The -3 is only attached to the x. So I could rewrite it if I wanted to. I could rewrite it as 7 times x to the -3. Well, that would be 7 times, and I have to flip my base because I have a negative exponent. They don't want it to leave it that way. So I want to flip my base. So instead of x over 1, I have 1 over x, and I keep my exponent with the x. When I do this math, I end up with 7 over x cubed. I multiply my numerators, multiply my denominators, and I get 7 over x cubed, and that's my final answer. Okay, now let's try another one. What if I had something like this? 5 to the -3 m to the 6th power. Well, I know the 5 to the -3, I have to change to a positive exponent. So I'm going to flip my base, make it 1/5, and I keep my exponent with the 5. I know it's being multiplied to m to the 6th. Well, that's a numerator because m to the 6th, I really could put a 1 underneath it and it'd be fine. When I do my math, I'm going to multiply the numerators, multiply the denominators, and I get m to the 6th power over 5 cubed. Then this part I can solve, so I want to finish it. So I get m to the 6th power over 125. Okay, another example that I can give you is something that has more than one exponent rule going on. So let's say I have something like 15x squared over 5x to the third. So right here, I see that there is some division going on here with the 15 over the 5 and some division going on here. So I can do both those. The 15 divided by 5, I can solve. That's 3. The x's have the same base, or these exponents have the same base, and they're being divided, so I can subtract my exponents top to bottom. So I'll get 2 take away 3, which is -1. So I'm going to get 3x to the -1. I can't leave it this way, so I know I'm going to have to flip my base on the x. So I'm going to have 3 times 1 over x to the first power, which is just 1 over x. So I get 3 over x as my answer. Now, some of you may see it right away that the 15 over 5 becomes a 3, and that you can see that 2 of these x's are going to cancel out, but there's going to be 1 left on the bottom. So you might know right away that your answer is going to be 3 over x. And you don't have to show all these steps if you see that. Okay, now I'm going to go over an example that is in your notes because we talked very briefly about what happens to the negative exponents when you don't have same bases. So, for example, well, here, let me erase this first. So in your notes, I gave you an example that looks like this. X to the 4th y to the negative fifth and z to the negative 2 power. Now, if I were to work all of this out, it would look like this. It would look like x to the fourth. The y to the negative fifth, I would have to flip my base. So I get 1 over y to the fifth. And the z to the negative 2, I have to do the same thing. I got to flip my base, which would be 1 over z squared. And then I got to try to work out what this answer is. Well, the x to the fourth, this is a positive exponent. So this is just a numerator because I can put a 1 underneath it and it'd still be x to the fourth. So I'm going to multiply all my numerators and I'm going to get x to the fourth. On the bottom, these aren't like terms, so I can't do anything really with these because I don't know what y or z is. So I just get y to the fifth z squared, and they're getting multiplied together. So this is the answer. What I want you to notice is what happens to the placement of the exponent or the bases with the negative exponents. So up here, this is a numerator, this is a numerator, and this is a numerator. But the ones that have a negative exponent end up to be a denominator in the end. The y and the z both ended up on the bottom. They ended up to be denominators, and that's because of the negative exponent. So when you have a negative exponent, it's actually going to switch positions in regards to numerator and denominator. So let's try one more example. So I give you one in your notes, and it looks like this. A to the negative 3 power, b squared, and c to the negative 2 power. But on the bottom, I have x to the negative fourth and y to the fifth power. Now, if I were to do all my flipping, flip my base, this becomes a fraction. So I really end up, this is going to look messy at first. This is going to look like this, 1 over a cubed. The b squared ends up to be the same. The c to the negative 2 ends up to be 1 over c squared. I'm going to divide that by this one, which this turns into 1 over x to the fourth, and the y to the fifth stays there. Okay? Now you get into a situation where you're dividing fractions. You're dividing things by fractions. You're taking a fraction, dividing it by something else. When you do all of that work, it will look something like this. This on the top, the b squared has a 1 underneath it. So you end up with 1 times b squared times 1. So on top, you have b squared. On the bottom, you have a cubed c squared. That whole thing is getting divided by this. Well, this is 1 over x to the fourth times y to the fifth. Well, the y to the fifth has a 1 underneath it. So you're just doing 1 times y to the fifth over x to the fourth. Well, that's just y to the fifth over x to the fourth. Now, we don't normally write stuff like this. You don't have multiple division bars here. But you have a fraction divided by a fraction. That's keep, change, flip. So that means you're going to take b squared over a cubed c squared. You're dividing that by this. Well, dividing by a fraction, if you have fractions involved with division, that's the same thing as multiplying, it's flip. So that really is multiplying by x to the fourth over y to the fifth. When you do that math, this is what your final answer looks like. B squared times x to the fourth over this, because these are all getting multiplied together and none of them have same bases. So this is your final answer. I want you to look at this answer, compared to this answer in the beginning. Everything that had a negative exponent that was originally on the top as a numerator became a denominator. The a and the c moved to the bottom and they kept their exponent. The x to the negative fourth, let me stay with the top. The b squared was a positive exponent, so it didn't change positions. It's still there. It's a numerator. Now look at the denominators in the beginning, in the original. The x to the negative fourth moved to the top. It was on the bottom as a denominator. Now it's a numerator. The y to the fifth was a positive exponent, so it stayed where it was on the bottom. So in your notes, I wrote some sentences in there that said, notice if you have a base that has a negative exponent as a numerator, it's going to move to be a denominator. If you have a base that has an exponent that's negative and it's a denominator, it's going to move to become a numerator. They're just going to switch positions. So you really don't have to do all of these steps. You can go directly from here to here. Okay, so let's just try this one, just for practice to figure out the movement. On the top, I have a to the negative 2. Well, it has a negative exponent, so I know since it's a numerator right now, it's going to drop to the bottom. So I'm going to have a squared on the bottom. This b has a negative exponent. It's on the top right now, so I know it's going to move to the bottom. So I'm going to have b cubed on the bottom. The c to the fourth has a positive exponent, so it's not going to move. So it's going to stay on top. The k to the fifth, it has a positive exponent. It's on the bottom, so it stays on the bottom. The m to the negative sixth has a negative exponent. It's on the bottom right now, so it's going to move to the top because of that negative exponent. And I'm done. Now, of course, if there was any numbers in the front here that you would have to solve, if I had like a 14 up here and a 7, I would actually do that math and get 14 divided by 7 is 2, and that would be a numerator over here. Now, the only other thing I want to add on this video is just to remember about 0 as an exponent. It's in your notes that anything with a 0 as an exponent just equals 1. So if you have 14 to the 0 power, it equals 1. If you have negative 7 to the 0 power, it equals 1. If you have anything inside a plus b to the 0 power, that's going to equal 1. Doesn't matter what these are, it's going to equal 1. If you have a million, to the 0 power, it's going to equal 1. If you have negative a million to the 0 power, it's going to equal 1. It doesn't mean the exponent is a 1, it means the whole thing equals 1. Okay, that's the end of this video. I hope that helps on your next assignment with negative exponents.